It's so close to being a duplicate Earth-Sun combo, so close, just a little far. It's today's Talkin' Science Story of the Week with Dr. Brad Tucker and me, Matt Miller.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
Brad, let's dive into the stories of the week. The most similar star and planet system or a solar system has been discovered. I believe that we still need to confirm this one, but it's looking very, very promising.
Yeah, and when we say similar, what we're talking about here is both the star, the sun, and the planet are very similar to our own, because that's one of the things that we're often looking for. We find lots of planets around other stars, and sometimes they're very similar in size and mass to Earth. But often, as we talked about last week, they orbit red dwarfs or other stars. So the Goldilocks zone, the zone where their water could exist, the heating, the potentially atmosphere is very different. This planetary system seems to have a lot of remarkable similarities to our sun and our Earth, which means that it's a great chance with the combination to think about, habitability and environments and those sorts of things, because there's a lot of emphasis nowadays on not just the planet, but the entire system as well. And so it's kind of a really unique discovery.
It is, of course, as I said, is still a planet candidate is the technical term until further confirmation's made that this is an actual exoplanet. But as you say, it's an Earth-like world. It's about 1.9 times the size of our planet.
Yeah, that's right. So, it's bigger, but not dramatically big. We know from what we calculate anywhere between 0.6 to 2.5 times the mass of the Earth will mean the planet is similar to Earth. We could look at our own solar system. In fact, Venus is pretty much the same size as Earth. And we think, well, why now it's not like Earth? Probably was in the past. We look at Mars. Mars is substantially smaller than Earth. But again, we think Mars was like Earth at some point in the past. And we think even planets bigger than that. We do think there is an upper limit, though, that when you start to get into what we call the super Earths, things 2.5 to 4 times the size of the Earth, the way the ground, the rocky bit in the atmosphere works, becomes very different than planets like Earth. So what that means for habitability and environments and those sorts of things, we're not quite sure. But in this case, it's similar enough that definitely puts it in the Earth-like range.
And the star that it is orbiting is Kepler 160. We've already confirmed that it has 2 planets orbiting in that system. This new study has revealed 2 additional ones.
Because of the way it is, I think it is a G-type star. So our sun is a G3 type star. It's a smaller G-type star, which means it has in terms of radiation to the planet, it's about 93% Earth, so it's about 93% the heat and the daylight and those sorts of things that we get here on Earth, which is, again, pretty much the same. And what we're starting to find is it's very remarkable that you get multiple planet systems. When Kepler started, it was really just under the idea that, hey, let's just see how many planets there are. And, what are there? And then they started to find more and more and more. And then a lot of these turn out to be multiple planet systems that, having multiple planets around a star is way more the norm than the exception, which is, it's a really exciting thing when we think about. Now, obviously, as you said, this needs to be confirmed. And it's always just quick to note why we talk about confirmation. In order to be a confirmed planet, we have to have 3 clear orbits, 3 clear rotations, 3 clear years. Now, if you want to find something similar to Earth, you need to wait 3 times 365 days, 3 years. So you have to wait quite a while to see those 3 transits. That's often why we find a lot of planets, like we talked about last week, that have 17-day years. It's easy to see those lots of times and realize they're real.
And one last thing with this story, Brad, is that astronomers are re-examining archive data from the Kepler Space Telescope, as you've been talking about. NASA retired that in October 2018. So just goes to show that it was just gathering so much data, more data than astronomers could process in real time.
That's right. And as I've talked about, we use Kepler for finding supernova and things that go bump in the night. And we have a backlog of over 50 objects we're still getting through because there's just so much data, as you said. And that's one of the exciting things about the way we view astronomy and data is that it's very open source because we realize no one person or group can do everything. And there's just so many things out there, and new techniques are developed by allowing it to be open access and open policy. We actually get a lot more science than hoarding onto it.
Awesome, Brad. Well, hopefully we get confirmation of this new planet soon, and we can keep studying it and really find more of these Earth-like planets. It's fun to talk stories of the week with you, Brad, and we're going to do another one tomorrow.
Great.